off we go. Not a lot of slides today, but a lot of content at the same time. So I'm excited. I'm going to talk about clones, messages, sending messages between things, like having little sprites talk to each other, and then we're going to make the game Pong, which hopefully you've heard of. It's like a classic, one of the first video games. So yeah, the first thing I want to talk about is how to clone stuff in Scratch. If you haven't seen that before, watch cool YouTube videos about it. But I would like to make copies of a single sprite, and that's called a clone. So let me fix my pens, and then we'll get started there. Why does it change all the time? I will never know. So I would like to make, for example, a field of stars. And you can imagine how horrible it would be. Let's go to Scratch, scratch.mit.edu. It would be disgustingly difficult if I wanted like 50 stars with our current knowledge. Let's actually, goodbye Scratch Cat, I'm going to delete the Scratch Cat for once. I'm going to get a new sprite. I think it's just a star. A star sprite. There's a star sprite. And then the backdrop we can choose. I think there's like a space backdrop. There's like stars there. Perfect. So here's one star. If you wanted 50 stars right now, you would just have to click choose a sprite again, add another star. It would be like star 2. You have to do that 50 times. That would be horrible. There's a better way. There's a way to make sprites clone themselves, and so they can have like copies of themselves on the screen. That's pretty easy. That's the better way for sure. All right. So let's generate 50 stars in 50 random spots with random sizes and directions, and this program will look like it's like we're going through the space at warp speed, and like they're going to bounce around. So let's do that, and I'll show you how it works. So my goal is to make 50 stars in random places. So it's all going to revolve around the clone myself block, which is right here in control. Create clone of myself. Okay? So that's pretty nice. So the star can clone itself, and if I click that block to have it run, it looks like nothing happened. But really, there's a second star now. See that? If I click it again, clones itself. I forget which one was the original. There it was. So now there's 3 stars. So if I just rerun this 50 times in a loop, right? Repeat this 50 times, I'll have 50 stars. Yeah? So let's do that. When the green flag gets clicked, I'd like to clone myself 50 times. So I'd like to repeatedly clone myself once 50 times. Yeah? So this, for example, right now is going to make 10 clones. If I do it to repeat 50, it's going to make 50 clones. Does that make sense? Not too horrible, right? So that's pretty cool, but look. Click it. Green flag. It's running, it's doing its thing. It's done. But we have 50 stars right now, right on top of each other. That is no fun. Okay, so let's make it a little bit better. So if you click the stop button, all the clones delete themselves, by the way. And get back to the original one. The one true star. So let's do the following. Let's have each star go somewhere different. And you can do that. There's a way. There's a way to have a program do a different thing. Have your clones do different things with this event. It's down here in control next to the cloning stuff. It's the when I start as clone event. So every clone, if we put some code down here, put some blocks attached to this event, every clone will run this code. See that? So every time it like gets birthed, it will run whatever we put into here. And so one thing I like to do for every clone is have it like warp to a random spot. So we have stars in every place, right? Go to a random position, every star. Does that make sense? So if I click the green flag, what's going to happen is like the original one true star is going to repeatedly 50 times clone itself. And then all of those clones are going to run this code. You see that? It's going to go to a random position. So that is why we see this happening. Okay? Feel free to change how many stars you make. Make 1,000 stars if you'd like. It'll like fill up the screen. It might run a little slow though. But you click stop to delete the clones. And of course, if you run it again, it's random, so the stars will appear in a different spot. But does everybody understand why this is doing its thing? The original star is going to repeatedly 50 times create a clone of itself. So that's 50 clones total. And then each clone will run the code in this event. When it starts as a clone, it's going to go to a random spot. Okay? Are you good with that? So that's a good start. Let's see. Let's let's also give them random sizes and directions, because I want to have them bounce around. Right? So let's do some random sizes as well. Let's in looks, I assume, right? Let's set size to some random percentage between like 25 and 100. So down here in operators, there's a random. Pick a random from 1 to 10. Keep running it. It'll pick something different every time. But I like to pick a random percentage now. Set size to a random percentage between, let's say, like 25 and 100. So now every clone, when it begins its life, it's going to go to a random spot, and then also set its size to a random size. So now we have some more variation. Isn't that cute? And of course, it'll be different every time. There they go. Any questions about what we got so far? Got some nice field of stars, slowly but surely. I'd also like these guys to bounce around, and so let's give them random directions as well, because every star right now has like the direction 90 because it's cloning the original star, which has that direction. So let's give them all random directions between like 0 and 360, right? Because those are all the values for angles to be. So let's set, in addition to the size, let's set the direction, and is that in so we can, like, you can always say turn a certain amount of degrees. You can also just say point in this exact direction, this angle. So we can give it a random number between like 0 and 360, all the possibilities. Okay. So now the stars are going to be a little bit tilted. See how they're not all facing the same way anymore? Like some are a little bit more to the left, some are a bit more turned to the right. Well, this one's like straight up and down. It's kind of cute. So that's a thing, and then that will allow us, because directions imply we can move in that direction, then let's make all of those stars bounce around, okay? Let's make them move in their current direction, like every clone, like it's gone to a random spot, it's at a random size, it's got a random direction now. So what we can do is repeatedly move in that direction, 10 steps, right? And if we just do that forever, that'll be fun. Move 10 steps in your current direction, and it'll give us animation. Look at them all float around. But eventually they're going to get stuck in the corners. Yeah. So we also need to include that block. If you hit a corner, bounce off of it. So that's if on edge bounce. Boop. So that's like constantly every clone star, move 10 steps. If it's on an edge, bounce. Move 10 steps on an edge, bounce. Move 10 steps on an edge, bounce. Eventually it will be on an edge after moving 10 steps, and it will bounce off. So that is why we see this. Whee! Any questions about this program so far? Interesting. I think they're moving a little too fast, so that's like too much warp speed. Let's move like 2 steps every time. That's cuter. That's better, I think. All right. So we're good with this program so far. One thing is that we have a star that is not moving. That's the original star. So I think it would be better if we made that one hide itself, because its job, the job of this original star is to like make all the clones, because all the clones have this program that like make them bounce around, do cool stuff. The original star is just like cloning itself. It should like hide itself when it's done, right? Because there are technically 51 stars right now. You include the original one. So let's have that star hide itself. Honestly, at the very beginning, it could be hidden even, but let's have it hide itself after it's done its work, and like show itself at the start, because we want the original stars. Like the clone stars inherit any properties of the star, so if we clone them while they're hidden, we won't see the clones. So let's like show the star at the beginning, the original one. There it is. Watch it disappear after it's made the clones. There. So that's one way to do it, I guess. You could also just hide it at the start and like show the clones when you're ready to. That's your alternative if you don't want to ever see the original star. Okay. So you got options, and like we've got 2 separate programs running, one for the original star, and that clones itself and hides itself, and then one for all the clones. Okay? We feel good? So the last thing I want to do with this program, I think, is I would like to make it look like the smaller stars are farther away. Because if we picked a random size and your size is like you're smaller, that should mean that the stars are farther, usually, right? And like if you go and look at a mountain that's far away, it's like a little transparent relative to mountains closer. So let's do that. Let's make that. Let's make smaller stars. If your size is smaller, let's make you more transparent, and that's the ghost effect in Scratch. Yeah. So we're going to have to do some math, because like if the size is 100, right? If the size is 100%, that means we would like the ghost effect to be like 0%, right? 0% ghost effect, because like it's the original size. It should be completely clear. But if the size is a bit smaller, if the size is like 25%, then we do want the ghost effect to be somewhere. Like we would like the ghost effect. An easy way to do it would be like subtract from 100, so maybe we can make it like 75% there. And so like you just think about what you want it to be where, and you can make a mathematical expression that like makes it happen within that range. So kind of what we can do is, right, we can set the ghost effect. That means transparency, right? Set the ghost effect to 100 minus whatever our current size is, and that's available to us as a variable. Okay? So yeah, that'll give 0 transparency if size is 100, and 75% transparency if size is 25. That'll be cool. So you can access your size. That is somewhere. Is it in looks? There it is. Yeah, so here's your size. You always have access to it. And so you can take that. You can take that and you can set the ghost effect to an expression involving that. So this is for every clone. I like to, after we've set its size, we can change its transparency. Let's do that. That's in looks. Let's change set the ghost effect to 0 if it's big and some larger number if it's small. It's going to be subtraction to 100 minus the size, because if the size is 100%, then ghost effect will be 0. If size is any smaller than that, the ghost effect will be non-zero, getting bigger as the size gets smaller. See that? So that's what I want to do with every clone. And now the smaller ones will have bigger ghost effects. And it's like they're farther away, floating around in space. So I think that is as much as I wanted to say about all that. Any questions about it? And of course, because it's random, like it's all different the next time you run it. But we got the code for the original star that just clones itself, hides itself, and then the magic is happening for all of those 50 clones. They're all running this code. To go to a random spot, set a random size, change the ghost effect relative to the size, go to a random direction, and start moving in that direction slowly, 2 steps at a time. You can make this bigger to make it look more like warp speed, and then if you're on the edge, you want them to bounce off. Like, boop, they're all bouncing. That's a fun, satisfying program, I think. Let me save it so that you can have it after class. Any questions about this before I go to a different example? That's clones. Pretty cool. So I just saved that, right? Now, for my next example, I would like to make I'd like to recreate that ghost program, because we did it a weird way. It was like the ghosts were always watching the value of a variable, like they were sitting in a forever loop. That's like a lot of work to just keep checking something that's probably never going to change very quickly. So that's like a lot of wasted effort on the computer to just keep watching the value of a variable. Instead, there's something different that we can do in Scratch. It's called message passing. It's here's the metaphor. In this concept of message passing, there's a sender, there's somebody who can shout out messages. And so for our example, it's going to be the Scratch Cat. The Scratch Cat will be the shouter of messages, the sender. And so if the Scratch Cat has something to say, he will shout out his message. Like he's going to send that to people. He'll write his little message and then he'll shout it out. Okay? So he can send that message to whoever wants to listen for it. That's the other end. So anybody can listen for a particular message. So we had those 3 ghost sprites, and the idea is the Scratch Cat will say, I believe in ghosts, or I don't believe in ghosts, and it'll shout out that, essentially, as a message, and then the ghost can listen to that, all right, and that's the concept. So you got, like, your skeleton sprite and your ghost sprite, and it was the bat, right, the bat sprite. They can all be listening to the message that the Scratch Cat will shout out, and then they'll just wake up whenever they hear it. So that doesn't involve a weird-looking forever loop that like is going to waste a lot of computational effort. Instead, they'll just be they'll be told, they'll be alerted whenever the message is passed to them. So let's recreate the ghosts example with this idea, And let me show you where that is in Scratch. So file new, everything blank. Let's call you the Scratch Cat. You deserve a name. And then, where is it? Is it in sensing? No. I forget where the messages are. There it is. It's in events. So you can make your own messages here, and you can say new message. You got a default message 1 that I don't know if you can rename, which is kind of weird. But yeah, it's going to be this broadcast a message, and then other people can receive it and respond to it with their own events. Okay, that's the idea. So let's recreate all the sprites in the backdrop. It's got like the woods, right? Spooky woods, Scratch Cat down here at the bottom, and we've got all the ghosts. Up top there was a legitimate ghost. Be over here, there was a skeleton, and then there was a bat. Cool. So here's the setup. So at the start of the program, let's just do it when the green flag gets clicked. The Scratch Cat can ask, hey, do you believe in ghosts? So we'll do all that again. That's all going to be the same. Ask, do you believe in ghosts, and wait. And then based on the answer, we're going to shout some stuff out. So the idea is there's going to be a message called, I don't know, let's call it show ghosts. We'll make a show ghosts message. So it's down here in it's in events, excuse me. So we want to broadcast a message to wake the ghosts up or make them hide. So let's have a new message called show ghosts. And let's also have a message called hide ghosts. So I'll make a new message here, hide ghosts. All right. So you can broadcast either one of those. You can shout it out. And the idea is that the ghosts are going to listen to these, and they'll wake up or go to sleep depending on this answer. Does that make enough sense? So the Scratch Cat that's shouting out this message, and the other people, the other sprites, can listen in. They can be like, when I receive the hide ghosts message, what do I do? When I receive the show ghosts message, what do I do? Does that make sense? That's going to be the secret. So let's work on the ghost right now. It's like when I receive the hide ghost message, when I receive, this just implies that they're going to listen for it if you put this there for the ghosts, right? So when I receive the hide ghost message, I as a ghost, what should I do? I should hide myself, right? One line, one piece of code. When I receive as a ghost the show ghosts message, what should I do as a ghost? I should show myself. And it'll just be constantly listening for that. So now if I broadcast show ghosts, of course the ghost shows itself still. If I broadcast hide ghosts, it's listening, and it hid itself. Show, it shows itself. Hide, it hides itself. So this message is being shouted out, and just like whenever it's shouted, the ghost wakes up and it's like, all right, I got some code to run. All right, I got some code to run. It's a lot cleaner than waiting in a forever loop to see if a variable changes. That's what we did last time. So that is going to be the secret. Let's give this same code to the skeleton and the bat. It's like the hide ghosts bit and the show ghosts bit. They're all going to do the same thing. So the skeleton, there they both are. They're on top of each other. So all three of those got the same code. Like when they receive the hide ghost message, they should hide. When they receive the show ghost message, they should show themselves. They're listening for that event, for that message to be broadcast, and then it's the Scratch Cat that broadcasts it. All right. So at the beginning of the program, we're not sure if the user is a believer, and so we'll maybe say, hey, ghosts, hide yourself at the start. So there's a hide ghost message that we can broadcast. And then if the user believed in ghosts, we just need an if. We just need to show them if they do, because otherwise they're already hidden right from the start. So if the answer will be yes, if the answer was yes, then we should show them. Let's see. So that's the idea. All right. So we got the Scratch Cat doing all this at the very start of the program. He broadcasts hide ghosts, and all the ghosts are listening for that. They receive that message and they hid themselves, each of them. And then the Scratch Cat is going to ask, do you believe in ghosts? And wait, if we type yes, then answer will be set to yes, and this will be a true statement, right? Yes will be equal to yes, true. And then it'll run the body of the block which will broadcast the show ghosts message, which all of these sprites are listening in on. They'll run this code when they receive it. Okay? Anybody can listen for it. Even the Scratch Cat could listen for it if he wanted to. You could just add a when I receive that message block. It's totally there. Totally possible. So that's essentially it. That's a lot cleaner. We can say no, of course, and they'll stay hidden because they were hidden at the start. It's a lot cleaner than the other one, I would say, because that involved making a variable and then having a forever loop watching all those variables with each of these. So like I click the green flag, the program would still be running right now with the old version because all these sprites would be in a forever loop just continuously watching that variable, which is not going to change more than once. It's only going to change for one split second and then it's all the same. It shouldn't have to be wasting time looking at that variable. Okay, so that is the cleaner way, I would say, with message passing. So broadcast to shout out the message, and then you could have events for sprites who want to receive that message and do something when they receive it, right? So that, I think, is what I wanted to say. Much cleaner, less code, message passing. Any questions about that? All right. So it looks like I changed a little bit differently. But here, let me give you my code. I did a little bit differently this semester. So here's the Scratch Cats code, this version. Boop. I would like you to play around with this idea. All right, try to take my example if you haven't made it already, recreate it, and then have it do something cool again. Maybe the same thing you did, pick a new thing, have it all, like, you've got options, right? You can have all the ghosts say boo when they wake up. You know where to put that, right? That will be in the when I receive show ghosts. Maybe you can respond to different answers, like maybe I believe in ghosts, and like only a couple of them show themselves or something. You can make a new message for that. But yeah, you have many options. Make the ghost fly around again, but have fun with it. I'll give you a few minutes to play around. And then we'll talk about Pong. Yeah, you can ask multiple questions, maybe. It would be. It should be. But you gotta save it. Looks like that file is first of all unsaved. And then by default, when you import stuff, you see how it's like pygame dot stuff. When you import stuff, it's pygame dot stuff. It's gotta be help bar dot.
And then I could say basically like using help bar.
That works too, and then you wouldn't have to save the dot.
Even if I do say using help bar, I could still put the dot and it wouldn't cause problems? Or is it either or specific? Strictly.
Not actually sure. You should try. Let me know. I can see either way. Another couple minutes to make something silly and fun, and then we'll come back. Okay, I can make that work. Interesting. All right. Give me 1 second. Okay, so hopefully you made something cool. You can play around with that some more. But that is where I want to stop for now. I'll save this and you can have it later too if you want to start from where I started. What else? So I think this is all I want to say about this program. Are there any questions about it or anything that you tried before I move on? One last idea today. So I'd like to make the game Pong. We'll make single player Pong. That's easier. But hopefully you've heard of this game before. It's like an old game, right? Old video game where you've got a little paddle on one side of the screen, or both sides. It's usually both sides of the screen, but we're going to make single player Pong. You got a ball. And the idea is the ball's moving around, and you need to like move your paddle enough to have it hit the ball, and it bounces off, and like it bounces off all the sides, etc., etc. Eventually, something like that. And if I draw it accurately, eventually you'll lose the game if you miss the ball. Let's say, boop, bounces around, you hit it again, then no clue why. I don't want to be locked in that, but eventually, if you miss it, something like that, then you should lose the game. Okay, that's the idea. So let's make Pong. We know what we need. We're going to need a sprite for the paddle and a sprite for the ball. So let's at least get started with that. So no scratch cat, sorry, unless you want the scratch cat to be the ball, which sounds a little mean. So there is a ball sprite, and then there is, I want to do it in this order. There is a paddle sprite, there is a ball sprite. Boop, paddle, ball. So there's the ball, there's the paddle. Paddle's kind of small right now, also it's facing the wrong direction. So you can change that direction back to 0 if you want, or 180, either one. And the size is a little weird. I guess I feel like the ball relative to the paddle is a little off right now. So let's change it to like, I don't know, 150. Is that better? I don't know. 175. That might be a little too easy. Let's do 150. I think that seems like a normal size to me. And then the paddle will be over here, and then the ball will just be doing its thing. So that's the start. What do we want to do next? Like, I don't know, the ball needs to move around, right? The ball needs to move around and like do fun stuff. So maybe when the green flag gets clicked, what should happen for the ball? By the way, I think what we would like, right, is that the ball should like go to a random spot, right? Because it should be a different game every time. The ball should go to a different random spot, and then it should pick a random direction to move in, right? Because like we again don't want the same game every time. So random spot, random direction, just like the stars. Because then it'll like move off in a different direction. And I think that should do it. So let's start with there. So when the green flag gets clicked, let's, for the ball, have it go to a random spot. Let's also have it pick a random direction, point in direction, random, just like the star 0 to 360. Boop. And then we want it to constantly move in that direction. Like right now, it's like, yeah, it's picking places and then moving. Let's have it start moving in that direction as well with a forever loop, right? Forever move 10 steps and like bounce off the wall if you're on the edge. So just keep repeating this, just like for the stars. So that's about it for the ball, right? Whee, there it goes. And so picks a random spot, points in a random direction, just starts moving in that direction as long as it can. And it's a different game every time. See that? That particular run of the program is showing something that is potentially a problem. What if the ball did that? You see that? What if the ball starts its way randomly right here and moves that way? You lose the game immediately, don't you? So we should probably fix that. Maybe for the ball, let's not have it go to a random spot anywhere on the screen. Let's maybe have it go to a random spot on the right half of the screen. That sounds a bit more fair. So like we'll draw a line. You know the line. It's y or x equals 0 line, right? Let's have the ball begins like somewhere on this half of the screen. Because then once it picks its random direction, even if it's facing right back towards the paddle, you'll have enough reaction time, hopefully. So let's do that. Let's not do completely random position. Let's do right half of the screen random position. So that's going to require some random x's and y's. Okay. So set x to something random, set y to something random. We don't want this anymore. And what random stuff do we want? So x and y. So x is the problem, right? We want x to be, like if it's over here, it's a negative x. See that? We would like it to be on the right half of the screen, which is a positive x. So positive or non-negative, I guess. So set x to be something between 0 and like what's over here. I don't know. How far can you go that way? I'm not really sure. About 200. Seems fine. And then y can be anything. Y is fine. It can be up or down anywhere as long as the x is on the right side. So it can go all the way from, I don't know, what is this, 150 to negative 150. That's fine. So y can go between negative 150 and positive 150. So do you understand what I just did? I'm making sure that the ball only begins its life on the right half of the screen. Make sure the ball starts on the right half of the screen so that we actually have a chance to win the game. All right, that first time. So now, and keep clicking the green flag, you see that the ball is picking random directions and random locations, but it's always on the right half of that screen. And that's what we'd like. Okay, any questions about that? So that's the balls program so far. What else? Now we need to move the paddle, right? There's a few ways to do it. We need to go to the paddles program, first of all. That was the balls program that we were working on. There's a few ways to move the paddle. One way would be just like for our platforming program, we had like when the up arrow is pressed, when the down arrow is pressed, and you can totally do that. I would like to do something different this time just to show you your options. Let's make the paddle follow the mouse pointer. So like you move the mouse, you don't even need to click. Like as long as you move the mouse, the paddle's going to move up and down. That seems a bit more convenient. So let's try it that way. So what we need to do then is when something happens, let's do green flag again because the ball's already hooked into the green flag. So like when the green flag gets clicked for the paddles program, let's have it forever match where the mouse is. So forever, look at where the mouse is. I think that's in sensing. Yeah, you got your mouse X and your mouse Y. Okay. And we want to move the paddle based on where the mouse is. So we can have like go to mouse X, mouse Y. Wherever your mouse is, these variables get set to that. So forever go, just follow where the mouse is. Put yourself paddle where the mouse X and mouse Y is. So if I run this now, do you see how the paddle is following my mouse? It's still doing something weird. It shouldn't be allowed to go over here, but it's closer to being better. That's not too bad, right? It's pretty cool. So instead of following it like this, what I'd like to do is only, like I want the paddle to only move up and down, right? If the mouse is over here, like just take the up and down portion of it. Does that make sense? Which is the Y portion of the mouse. Don't even worry about where the mouse's X is. That's better this way, okay? Just change the paddle's Y to match the mouse's Y. Keep its X, whatever it's already been over here. Like keep it negative 192, whatever I have. Right? Just change the mouse's Y. That's better. So set Y. Just follow the mouse Y. Nobody cares about the mouse X because the paddle shouldn't move left and right. Does that make sense? What's happening right now? It's setting the Y only of the paddle to whatever the mouse's Y is. So even if the mouse is way over here, it's just taking the up and down portion of it, the Y part. And that is very convenient, I would say. That's a nice way to play the game, I think. Okay? Any questions about what we got going on so far? Because we're almost there, right? We just need to hook up the one thing right now is like we need to hook up the paddle to the ball, right? We need to make it bounce off. And then also we need the ability to lose the game. Because otherwise, what's the point, right? So when it hits that left wall, that's like the special secret wall you can't ever hit. So you should lose the game at that point. Okay? So let's figure this out. We have our paddle. We have our ball. How can we notice when one has hit the other? Any ideas? There's a block for that. The ball's coming in this way. How do we know? It's one of the blue blocks. It's touching. So that keeps track of whether or not it'll be true if it is touching, false if it's not touching. So the ball's coming in, and it hits the paddle. Where do I want this? I don't know. I like that it was 192 for some reason. When the ball's coming in and it touches the paddle, this will be true, right? Touching, it's always from the perspective of whose program this is. Let's have the ball check if it's touching the paddle. So this is the ball's program right now. We can change, is it touching the mouse pointer? No, let's change if it's touching the paddle. Because if it is, like it is right now, it'll be true. And if it's not, it'll be false. See that? So it's either touching or not touching, and this block will give us that. This check will give us that. All right? So this is kind of the setup. The ball, it's moving on its merry way, and then it has a lot of checks. Like it just moved 10 steps in its current direction. The ball could be over here, moving this way. It could be on the edge, so it should bounce. It also might be hitting the paddle right now. So if it's touching the paddle, we also want to bounce off of that. See? So it's like if on edge bounce, let's also have an if touching paddle bounce kind of thing. So just a bunch of checks now. If on the edge bounce, if touching paddle, also bounce. All right, just like move in your direction, like maybe you're touching the edge. If so, run that, bounce. Otherwise, move in your current direction, maybe you're touching the paddle. If so, bounce. All right? So the way that you would want to bounce is like this, right? The ball's coming in this way. You do want to bounce off this way, but I want you to think about how to do that. I'll show it to you at a different time. Like the ball's coming in this way, like it should be bouncing off this way, right? That's like the normal way to bounce off. But let's make it easy on ourselves right now. I want you to think about how you might fix it and do it the normal way. Let's just make it do a 180. That's easier. So like when you hit the paddle, let's just have it bounce off, do a 180, because that's very easy direction change for us. And it'll just bounce off the opposite way that it was coming. So it's not very natural, but it's still bouncing. So if the ball has hit the paddle, like it's coming in, it's touching the paddle right now, if that's true, we would like the ball to change direction. That'll make it fly off in the other way, right? So how do we do that? And that's going to be, dun dun dun. You can turn left or right because it's 180, right? It's either way, it doesn't matter. 180. Do a 180 if you're ever touching the paddle. So it's like forever the ball just keeps on doing these checks. Move in your current direction. If you're on the edge, bounce, sure. And then if you're touching the paddle, also bounce off of that. Boop. So if it's on the edge, it bounces after moving. If it's touching the paddle, also it'll bounce. So all these checks, just like one after the other, it's fine because like two of these won't be true at the same time, in theory. So that's going to be the program for the ball. It's got a lot to worry about, doesn't it? But that's going to do it. Look at it. Boop. There it goes. Are there any questions about why it's doing it? Why it's working the way it's working? So we're bouncing off of doing a 180 every time we hit that ball. That's already satisfying. So try to think about, like, there's a mathematical way to bounce off in the direction you would assume it should bounce off, like the way it's bouncing off walls, for example. Think about that. We'll try it again later, and I'll show you the cool way, but this is a good enough way for now. Then finally what we need to do is add the ability to lose the game, okay? Because if the ball ever hits that left wall, that's like you missed it with the paddle, you suck, and you should have lost. The game should have ended, okay? So that's the last piece of the puzzle. There's a few ways to do it. You can have the ball keep track of that again if you'd like. You have the ball be like, all right, if my X ever gets this far over here, like that means I'm past the paddle. That's one way to do it. You just check if the X is really small for the ball. If so, that means it must be to the left of the paddle and it's about to hit the wall, or it just hit the wall. So that's one way to check, and that seems difficult. You could do it. It's like if my X coordinates, like where is that motion? If my X position is smaller than, what's the paddle's X? If it's smaller than negative 192, then it must be hitting the wall right now, then we're done. It went past the paddle. So that's one way to do it. Another way, which is probably the easier way, would be to solve the problem with another sprite. So here's another sprite. There's a line sprite. And this is totally sidestepping the issue. We'll change the direction to 0. If you just put this line sprite right here, do you see how if the ball ever touches it, it should be game over? Then you just check that. So that's pretty much that's the easier way to do it, in my opinion. So when the green flag gets clicked for the line, this is the lines program now, it can just keep watching. Hey, is the ball touching me? Sense. So it's always from the line's perspective because this is the line's program. So is the line touching the ball? If that is true, we'd like to stop the game. So if I am touching the ball, if this is the line's program, so if the line is touching the ball, I'd like to stop the game. All right? We'd like to stop the game. And there's a way to stop the game. It's called the stop block. It's the block that presses the stop button, essentially. So that's over here in control. You say stop all. And look at how cute this is. You can see that nothing can come after the stop block. See, there's no way to hook in underneath it. It must be the end of everything. That's kind of fun. I like that they did that. So that'll stop the program. And for example, it's going to stop the forever loop for the ball. So it won't be spinning anymore. So this is the lines program. So like if I lose the game, the line touches the ball, like there. It's going to run the stop block, and now everything stops. I can't move the paddle anymore. The ball's not moving anymore. Like it pressed the stop button, essentially. Are there any questions about that? It's kind of neat. So that's how you lose the game. Let's see. How do I want to do that? What do I want to do? Let's see. That'll be fun. So, okay. Let's make one last thing. Let's make a custom you lose sprite that gets displayed when you lose. Via a message. Let's do it that way. That'll practice the things we've learned. Let's make a new sprite, and instead of clicking choose a sprite, I'll go to the paint part. So I'll paint a new sprite myself. And so I click the T here for type text, and it'll be like game over. And like a sad face or something, I don't know. And you can change the size of this, of course, and center it if you'd like. But that's the idea. So there's my game over sprite. You can put that wherever you want. Put it down here if you'd like. So that'll work. And essentially, we'd like this sprite to get woken up when it's all done. So I'll go back to the code right now. I'm in the costumes. Go back to the code, and I'll call this sprite one like the game over or something. Game over sprite. And the idea is we want this to be displayed when the game is over. So like at the start of the program, this game over sprite should not be shown. So like when the green flag gets clicked, we should not be showing that game over sprite because the game is not over. So like green flag gets clicked for the game over sprite, hide yourself. And then if the game is ever over, the line discovers that, right? We'll just put something above the stop to show the game over sprite. And let's do a message for that, just like we did for the ghosts. So that is in events. And so let's make a broadcast. Let's not say message 1. Let's make a new message called game over. Okay. So this will shout out game over. And then this game over sprite can be listening for the game over message. And it'll be like, when I receive the game over message, I better show myself, because that's going to show this game over sad face. Does that make sense? So now, there's a lot going on. So when the line, this is the lines program now. The line is understanding, it's figuring out, like, if I ever lose the game, this is the line's job. So if the line is ever touching the ball, it will broadcast the game over message and then stop everything. Boop. And so what it just did, it broadcast the game over message, and this was the game over sprite doing that. It started out hidden, of course, and then it received that message right before the program got stopped. It showed itself real quick, and then the line sprite said, stop everybody, we're done. So that is a bunch of sprites working together to make something very, very cool. So that is the game, and let's see. Sometimes the ball goes into a weird spot. So you can play it, it bounces off, it works, and the game eventually ends. You can restart it. For some reason, I see. I believe the game ends immediately for a reason. Let's see, how can I fix that? Dun dun dun. Twice. That is interesting. Let me think about that. So it looks like, bam, it says game over. And if I click to rerun the program, it again says game over even though the ball is over here. And I think it's just the line too quickly noticing that the ball was still over here before it got moved. So maybe what I could do is have the line wait. Like at least a second before we think the game is over. That's a potential option, but I don't like it. Something like that. Let's see if that fixes it. If I rerun the game. Yeah, that was the problem. That's disgusting, though. Sorry. So sometimes you need to do something silly like that to make things work. There's a bug if we don't have this. The line still, the ball takes a second to move to a random spot after losing the game. And so the line thinks the ball is still touching it at the start of the program otherwise. That's what we're preventing, which is disgusting, but that's one way to do it. Okay. So all right, let's think about this. So the paddle has a very easy job. The paddle's just moving up and down, setting its Y to the mouse's Y. That's pretty nice. The ball has maybe the hardest job. When the green flag gets clicked, it's going to a random spot, like random spot, random spot, random spot, random XY on the right side of the screen. It's pointing in a random direction to make a different game every time, and then forever, constantly, until the program's over. Somebody stopped it when you lost the game or you press the red button. Then it's going to move 10 steps in its current direction to produce animation. If it's on the edge, like it is now, it'll bounce. And then otherwise, it can also check, it needs to check every time as well, after it moved, am I right now touching the paddle? Did I just move and hit the paddle right now? If I did, then I'll turn a 180. Okay, so that's what the ball's doing. Then the line is checking, hey, after a second at least, it's checking, hey, is the ball touching me? It starts forever. After a second, it starts checking forever until the end of time if the ball's touching it. If it is, it broadcasts the game over message, and that's going to stop. After that, it stops the entire program. The game over message is being listened to by this game over sprite, which starts its life hidden. When it receives that message, listening to it, it shows itself, shows game over, and that, my friends, is Pong. All right, so I'm going to give you this for sure. Save to your computer. So you'll have this. Are there any questions about any of this? Do we follow it enough? Definitely a good one to study. Practicing a lot of stuff we should. But that, I think, is all that I wanted to say. You can make this yours. I encourage you to try like making a 2-player Pong. Maybe like the mouse for one and the keys for another one, or like the W and S for the left one and the up and down for the right one or something. That's a thing. So consider that. But that, I think, is all that I wanted to say today. If there's no new questions, so let me give you, before we go, and let you work on it, your new programming assignment, let me give you your new programming assignment. So this is programming assignment 3. It will be due the 15th, so in a week, just as usual. So if you're doing the Scratch assignments, here's your project for the week. I would like you to implement the Space Invaders program in Scratch, just by following this cool guy's YouTube video instructions. So he's building Space Invaders, and it's in Scratch, but he's using tacos apparently as aliens. You can choose whatever you want. Let's see. There's a good example of him running it. Come on. There he goes. See him like moving his little thing at the bottom, clicking to shoot, and then it was just tacos were following his enemies. So you can recreate that, and it will be helping you practice a lot of stuff that we learned. So just please do that. Follow this instruction, recreate this Space Invaders Scratch program by following the tutorial. You can change as much as you want, as long as all the features are there. Like you can make the enemies different. You can make power-ups if you'd like, that like make you shoot more. Have fun with it, but that's the minimum I want you to recreate. All right. So any questions about that? So Space Invaders is your project, your Scratch program. Yes. Oh, I'm not going to show you that today. I want you to think about it. Try it yourself. I will show you that in a future class. The way to do it right. Yeah. But I want you to think about it for a while. That is a good question, though. It's gonna take some math. Think about it. Let's see. Yeah, so that's that. So we're good with Space Invaders. And then, again, make sure to upload a video of your program running with your code visible. I need to hear you, all right? Starting from now, I know we had maybe some technical difficulties recording our last programming assignments. I want to hear you. I will give you a 0 if I cannot hear your voice explaining the program. I need to know that you understood it, right? And not just blindly follow the instructions. That's important. So that's that. And then if you are a programmer, you're doing the Racket programs, please read these sections of the book and do these exercises. 9 and 11 will be your exercises for the week, and then just upload a video as usual with your voice again, please. Okay, and let me know if you want a custom one and you want to like do something different. So those are your assignments, depending on which camp you're in, and it will be due in a week and a day. Are there any questions about any of that? All right, so that's all I got for you then. Go ahead and get started. Question? Yeah.